Welcome to the lecture series of numerical methods. Today we are going to discuss about solution of one-dimensional heat equation. The PDE, partial differential equation of the form dou u by dou t equal to c square dou square u by dou x square is called one-dimensional heat equation. The one-dimensional heat equation is dou u by dou t equal to c square dou square u by dou x square. So, using this one-dimensional heat equation only, we are going to see the problem. So, under the one-dimensional heat equation, the method is called it as Schmidt method or explicit method. What is the Schmidt method? The Schmidt method says that consider the rectangular mesh in the xt plane. Here it is not xy plane, it is xt plane with the space h along x direction and k along t direction, denoting the mesh point x comma t as ih comma jk as I comma j. Then dou u by dou t equal to 1 by k u of ui comma j plus 1 minus ui comma j, and dou square u by dou x square equal to 1 by h square into ui minus 1 comma j minus 2 ui comma j plus ui plus 1 comma j. Substitute the above equations in equation 1, we can get ui comma j plus 1 equal to alpha ui minus 1 comma j plus 1 minus 2 alpha into ui comma j plus alpha into ui plus 1 comma j, equation 2, where alpha equal to k c square by h square is the mesh ratio parameter. The formula is to find the value of u at the point I comma j plus 1th mesh in terms of the known function values at the point xi minus 1 comma xi and xi plus 1 at tj. This relation between the function values at the two time levels j plus 1 and j, and hence this is called two-level formula, and the equation 2 is called Schmidt explicit formula, which is valid only for 0 less than or equal to alpha less than or equal to 1 by 2. In particular, when alpha equal to 1 by 2, then equation 2 becomes u of I comma j plus 1 equal to 1 by 2 into ui minus 1 comma j plus ui plus 1 comma j. The value of u at xi at the time t j plus 1 is the mean value of the values u at the time tj. This relation is known as Bender-Smith recurrence equation, which gives the value of u at the internal mesh points with the boundary conditions. So, this is what the Schmidt method. What is the Schmidt method says? The Schmidt method says that instead of xy plane, here we are going to take xt plane. That is the first thing we have to remember. Here we are considering the xt plane. We know very well that h is nothing but the step size of x, or h is the difference between the x data, and here k is the step size of t direction. So, denoting a mesh point x comma t as ih comma jk, or simply we can denote the point as I comma j. So, here we are going to use some condition. The condition is alpha, that alpha value is k c square by h square. If this value alpha is called it as ratio of the parameter alpha. For the Bender-Smith method, the parameter is alpha. Look at this equation 2. Equation 2 is called it as Bender-Smith formula or explicit formula. Here we have the parameter alpha. Base the value of alpha only we are doing the problem. Here we have this formula is valid only for 0 less than or equal to alpha less than or equal to 1 by 2. So, when we can use the Bender-Smith result? Only when the parameter takes the value 0 to 1 by 2, we can apply the Bender-Smith result. If particularly when alpha equal to 1 by 2, then the Bender-Smith relation becomes as ui comma j plus 1 equal to 1 by 2 into ui minus 1 comma j plus ui plus 1 comma j. So, when doing the problem, when we are doing the problem, if we are getting the alpha value is 1 by 2, instead of using the recurrence equation 2, we are supposed to use this result, ui comma, the same only, it reduced like this. Okay, so when alpha equal to 1 by 2, we are supposed to use this result. When 0 to 1 by 2, we are supposed to use this equation 2. That is what we have discussed in the Bender-Smith relation. Bender-Smith equation is also known as explicit relation. Okay, so in the question paper, using Bender-Smith or explicit, both are same only. Now we will go for the problem. Look at the question. Solve dou square u by dou x square. Dou square u by dou x square equal to dou u by dou t. Given u of 0 comma t equal to u of phi comma t equal to 0. And u of x comma 0 equal to x square into 25 minus x square. Find u in the range taking h is equal to 1 and up to 3 seconds using Bender-Smith recurrence equation. Instead of this Bender-Smith recurrence equation, it can be given explicit method also. So the question it's given, the first one is heat equation, dou square u by dou x square equal to dou u by dou t. We have to compare the given equation with the general equation. What is our general heat equation? Dou u by dou t equal to c square into dou square u by dou x square. Some of the question or some of the authors used to have the, instead of c square, they may write a square also. It doesn't matter, a square or c square or any constant, lambda square, everything comes same meaning. So dou u by dou t equal to c square into dou square u by dou x square. This is the general equation of one dimensional heat. So here in the question it's given that dou square u by dou x square equal to dou u by dou t. So in the place of the constant, here we are having 1. So in the problem when you are doing, we have to take the value of c or a equal to 1. First thing. And the next one, it's given that u of 0 comma t equal to u of phi comma t equal to 0. As we have discussed earlier, u of I comma j or u of x comma t. So it's understood that the first place is x value. So the x value starts with 0, ends at phi. So in the starting and the ending value of x is 0. That is what given. Actually it's boundary value. Okay, and the condition is given u of x comma 0. That means t equal to 0. Okay, u of x comma 0 equal to x square into 25 minus x square. This is the condition is given. Find u in the range taking h is equal to 1. That means the step size of x is 1 and up to 3 seconds. That means the t equal to 3 seconds using Bender-Smith recurrence equation. First we are trying to understand the question clearly. So heat equation is given, boundary condition is given, one more condition is given, and then we are supposed to find the mesh value with this h is equal to 1 and t up to 3 seconds. Okay, now we can go for the solution. Look at the solution. The given equation can be written as, not necessary, you can write the given equation as it is also, it doesn't matter. Okay, uxx or dou square u by dou x square equal to dou u by dou t, both are same only. So as I told you already that in the place of the c or a, in this question it's 1. Okay, so a equal to 1. Also given in the question h is equal to 1. H is nothing but step size of x. Okay, to use the Bender-Smith recurrence relation, we have a parameter. What is that? Alpha. As I told you already that alpha is, the condition is k by h square a equal to 1 by 2. Why here we are taking alpha equal to 1 by 2? Look at this, alpha equal to 1 by 2. You know why? Because in this question it's given that h is equal to 1. As I told you already that h is nothing but step size of x. So what about the step size of t? Step size of t is nothing but k, right? Here we have mentioned that. Look at this theory part. In the x direction it is h and k along the t direction. So when you are noting a mesh point x comma t, it can be written as ih comma jk. So x takes the ih and t takes this jk. So it's understood that jk for the t direction. So k for the t direction. So look at our question. In the question, k value is not given directly. So if it is the case, we are supposed to take the alpha equal to 1 by 2. Is it clear why we are taking alpha equal to 1 by 2? Because the k value is not given in the question. To find the k value only, we are taking alpha equal to 1 by 2. If suppose in the question h, k and a, all the values are given, we can going to find the value of alpha, whether it comes 1 by 2 or less than 1 by 2. According to that only we are using the formula. So in this question the k value is not given. Because of that reason only we are taking alpha equal to 1 by 2. So we know the formula for alpha. Alpha is nothing but k by h square a. We need the value of k. So you can cross multiply this. K equal to a h square by 2. A value is given in the question 1. H is also given 1. So we can get the k answer is 1 by 2. Since h is equal to 1, the step size of x. Is it right? So now the given condition, we got the value of h and k. Now we will go for the question. The question is given that u of 0 comma t equal to u of phi comma t equal to 0. As I told you already that this is nothing but the boundary condition. So the condition is given u of 0 comma t equal to u of phi comma t equal to 0, and one more condition is given, u of x comma 0 equal to x square into 25 minus x square. We know very well that x is equal to IH. Here h is equal to 1. So x is equal to I. Right? So instead of x we can make this place as u of I comma 0 equal to I square 25 minus I square. We can call this as equation 1. So what is our first step? We are going to give the value for I here. I is equal to 1, 2, 3, 4. Why we are stopping up to 4? Because it is given the last value of x is 5. That is the reason why we are making the place only 4. Here the starting value is 0, ending value is 5. So in between I takes the value 1, 2, 3, 4. That is the reason why we are substituting I equal to 1 to 4 in this equation 1. So when you are substituting I equal to 1, we are getting the value as u 1 comma 0 equal to 24. I equal to 2, we are getting the value as 84. I equal to 3, 144, and I equal to 4, we are getting u 4 comma 0 equal to 144. So how we are doing the problem? First we have to make a table like this. To avoid all the mistakes, you can take a table like this. In this one the I value, it doesn't mean that you are supposed to take the I in the horizontal way, j in the vertical way. It's not like that, choice is ours only. So I takes the value 0 to 5 and j takes the value 0, 1 to up to 6. How we are writing this j value here? Because we know very well that x is equal to IH, x is equal to IH. Here h is equal to 1, so x is equal to I. This is one condition. And the next one is t is equal to jk, isn't it? And here t equal to up to 3 seconds is given in the question, right? So when you are substituting j equal to 0, what will happen? J equal to 0, 0 and anything 0. That is the reason why first here we are making j equal to 0. When j equal to 0, t will also 0. Then substituting j equal to 1 here, at the same time k equal to 1 by 2. So what will happen? T equal to j equal to 1, k equal to 1 by 2. Okay, so t equal to 1 by 2, that means actually t equal to 0.5. Then the next value. Okay, next j equal t equal to, look at this one, j equal to 2 and k equal to 1 by 2, 2 by 2 it is 1. Likewise we are doing this up to 6. Why we are going for j equal to 6? When you are substituting j equal to 6 here, t equal to j equal to 6, k is 1 by 2. So what will happen? T equal to 3. So up to 3 only it's given in the question, t equal to 3 seconds. That is the reason why we are making the j value up to 6 here. Hope everyone it's clear. Okay. So now look at the question. The boundary condition is given that u of 0 comma t equal to u of phi comma t equal to 0. That is the first condition we have taken in the answer. That means what? The boundary value, that is all the value of I equal to 0. Okay, the first column fully 0. Likewise, the last value is 0 because it's given in the question u of 0 comma t and u of phi comma t equal to 0. And the next condition is given in the question. Using that condition only, we have substitute the value I equal to 1, 2, 3, 4. So substituting the value of I equal to 1, 2, 3, 4, we got the first answer. That value only here we are going to write it here. So the values of I equal to 1, we are getting 24, and the next value is 84, and the next one is 144, and the next value is 144. How we are writing the first row value? Using the second condition. So up to this the first condition is over. Now we are going to use the result of Schmidt method. Okay. So here t equal to kj. That is what I have told you already, that here we are doing up to t equal to 3. That means what? T equal to j is 6 and k is 1 by 2. That is the reason why here we are getting 3. So when j equal to 6, we are getting j equal to 6, you are getting t equal to 3. That is the reason why we are stop up to j equal to 6. Okay. So now we are going to fill all the remaining values by using the Bunter-Smith result. Okay. So in this relation only we are going to do the problem. So how we are going to do the problem means, first we are going to take the value of I. Okay, look at this one. U of I comma j plus 1 equal to 1 by 2 u I plus 1 comma j plus u I minus 1 comma j. We can call this as equation 2. How we are taking this relation? When alpha equal to 1 by 2, the Bunter-Smith relation is this is what. Okay. So in this only we are going to find all the remaining value of the table. Our aim is to fill the values of the table. Okay. So first how we are going to fill the value? First you are going to give the value of j. What is the j value here? J equal to 0. So when you are substituting j equal 0 in equation 2, what will happen? Put j equal to 0 in equation 2. Okay. So this equation become u I comma 0 plus 1, it will become as 1, 1 by 2 u I plus 1 comma 0 plus u I minus 1 comma 0. Is it clear? So first we have given j equals 0 in the equation 2. Now after given the j value, the equation reduces u I comma 1 equal to 1 by 2 u I plus 1 comma 0 plus u I minus 1 comma 0. So after this obviously we are going to give value for I equal to 1, 2, 3, 4. When I equal to 1, what will happen? u 1 comma 1. So that is nothing but u 1 comma 1. That value we are going to find. When I equal to 2, what will happen? u 2 comma 1 and u 3 comma 1, u 4 comma 1. That is was the first step of the problem. Okay. So when I equal to 1, what will happen? This will become as u 1 comma 1. I place you have to put 1. So u 1 comma 1 equal to 1 by 2 into u I plus 1. That means 1 plus 1, 2, u 2 comma 0 plus 1 minus 1. Okay. u 1 minus 1 is 0. So 0 comma 0. So which is equal to 1 by 2. Look at the table, u 2 comma 0. Okay. u 2 comma 0. That's nothing but what? 84. So 84 plus u 0 comma 0. 0 comma 0 is 0. So 0, which is equal to 84 by 2. What is that? 42. So our first value u 1 comma 1 is nothing but 42. So u 1 comma 1 is nothing but 42. That is the reason why we have make a table like this, so that we can avoid the mistakes and we can easily find the values from the table. Previous value we can easily take it out. Okay. Now what is the next value? Next value is I equal to 2. So put I equal to 2. So what will happen? I equal to 2 means here it will become as u 2 comma 1. So u 2 comma 1 equal to 1 by 2 into I plus 1. So 2 plus 1 is 3. So u 3 comma 0 plus 2 minus 1. Okay, 1 comma 0. Okay. So now 1 by 2 into u 3 comma 0. u 3 comma 0. Look at the table. u 3 comma 0, 144 plus u 1 comma 0, 1 comma 0, 24. Okay. Like that we can find all the values in the table. So likewise all the values in the table we have to fill. So when I equal to 1, we got the answer as 42. So I equal to 1, 42, I equal to 2, 84, and I equal to 3, I equal to 4. Likewise for all the values. Next what we are supposed to do? We have to do this j equal to 1 in equation 2. After that j equal to 1, again I equal to 1, 2, 3, 4. That is the next row value. Likewise j equal to 2. And then I equal to 1, 2, 3, 4. Likewise, we are supposed to fill all the values in the table. So this is the way we have to do the problem under Bunter-Smith method. We have to keep in our mind that x is equal to IH and t equal to jk. These are the two important things, x and t direction. Here x and t direction only. So x is equal to IH. In this question h is equal to 1. That is the reason why we have taken x is equal to I and t equal to jk or kj. So we have to give the value for j equal 0, 1 to 3. Here how to stop the j value means it's given in the question that t equal to 3 seconds. Okay, so it's given in the question up to 3 seconds the problem. So that is the reason why we have taken t equal to 3, that is means j equal to 6, t equal to j into k, that is 6 into 1 by 2, we are getting t equal 3. That is the reason why we have taken the j value up to 6. Only the first row we have to take the given first condition. Using that we got the answer for the first row. First column and the last column is nothing but boundary conditions given in the question. And the remaining values we are using the Bender-Smith relation. If alpha equal to 1 by 2, we are supposed to use this result. If alpha lies between 0 to 1 by 2, that is 0 less than or equal to alpha less than or equal to 1 by 2. In that case, we are supposed to use this relation. Bender-Smith equation is also called it as explicit method. When we are using this Bender-Smith method only for the one-dimensional heat equation. In the heat equation, dou u by dou t equal to c square. So in this place, what is the number comes, that value takes for c square. So based on this only we are finding the value of the mesh points. Okay, and here we have to remember in our mind that x comma t equal to ih comma jk, or instead of I comma j. Okay, so this is the way we have to do problem under Schmidt method or explicit method. Okay, thank you for watching.